I'm Siew Ho, metric number 1938851. Today I'm going to present about review on treatment of hospital wastewater by removing phosphorus and ammonia with activated carbon and zeolite. Wastewater from hospital contain high concentration of phosphorus and ammonia which come from patient excreta, medicine, detergent, or residue of food. This contaminant will cause eutrophication and also toxic to aquatic life. Based on research has shown that the final disposal to river from hospital contain 1.75 mg per liter of phosphorus and 5.22 mg per liter of ammonia, which does not fit the parameter from Malaysia National Water Quality Standard with 0.2 and 0.3 mg per liter. The ways of removal include chemical precipitation, biological treatment, and adsorption. Activated carbon and zeolite as an adsorbent has been used in this project. This is because it is more economical, efficient, and environmental friendly. The objective of this project is to compare the efficiency of activated carbon and zeolite in removal of phosphorus and ammonia, and second, comparison of absorption of phosphorus and ammonia by activated carbon and zeolite by Lamia model and also front dish model, and to investigate the fitness of absorbent for both models, and last but not least, to investigate the required dosage of absorbent. First of all, I'm going to discuss about activated carbon. It is small size and has porous surface which increase the surface area, and this allows the activated carbon suitable for absorption. Contaminant has been attached to the porous surface of activated carbon through hydrogen bond and van der Waals force. They stick together and precipitate out of the solution. Next is zeolite. It is a mineral component formed in altered volcanicrustic rock, and it has porous structure, three-dimensional structure of tetrahedra ArO4 and SiO4, and it is negative charge, so it can be used as cation exchanger. Next, I will discuss about Lamia isotope, which used to discuss the equilibrium between adsorbate and adsorbent system. The below is the equation, and the assumption of this model is adsorbed molecule on the adsorbent surface has no interaction. In this project, raw data of the amount of contaminant removed by adsorbent at different doses were collected, then plot the graph by using the linear equation to find the constant P and Q max. Then next is front dish isotope. With the same as Lamia isotope, we get the raw data and plot the linear equation. And the assumption of this isotope is absorption of the molecule on the absorbent surface is in multi-layer. Next is to discuss the efficiency of activated carbon and zeolite in removing phosphorus and ammonia. Amount of contaminant removed by adsorbent at different tight contact was correct from journal and calculate the absorption capacity. Results show that activated carbon has higher absorption capacity to remove phosphorus. This might due to the surface of zeolite has constant negative charge. Thus, it is very difficult for it to remove phosphate, which is also in negative charge. Next is comparison absorption of phosphorus by activated carbon and zeolite by Lamia model. Results show that activated carbon has higher maximum absorption capacity and higher affinity of the phosphorus to the absorption site, and the separation factor of activated carbon is in the range of favorable absorption. Well, when discussed with front dish isotope, it showed that the activated carbon has higher absorption capacity and absorption intensity than zeolite. Next is to discuss the absorption of ammonia by Lamia model. Results show that activated carbon has higher affinity of the ammonia to the absorption site. However, when discussed with the front dish isotope, zeolite showed that it has higher affinity to ammonia compared to activated carbon, but the separation factor of activated carbon is in the range of favorable absorption. Next is to discuss the fitness of Lamia and front dish absorption isotope for the activated carbon and zeolite. The results show that all the absorption activity is more complete with the front dish isotope. This can be shown by the R-square value. The higher the R-square value indicate that the farm performance is follow the index closely. And this shows that they didn't follow the Lamian theory where the absorbed molecule on the absorbent surface has no interaction and all the surface sites have the similar affinity for the absorbate. And they fit the front dish theory where the number of absorption sites of the surface is not equal. Next is to calculate the required dosage of absorbent. to remove the 5.4 mg per liter of phosphorus to 0.2 mg per liter and 17.6 mg per liter of ammonia to 0.3 mg per liter. And the most suitable model is Frandish model with activated carbon 31.75 gram. And Zeolite is not recommended to use in the process of removing phosphorus due to the too low efficiency. Next is to consider about the other reason that affect the absorption of activated carbon, which is pH. The most optimal pH is 7. This is because at low pH, the ion might be complete with the contaminant for the absorption side. The conclusion for this project is the Lamia model showed that activated carbon has higher affinity for phosphorus and ammonia compared to Zeolite. Well, based on Frandish model, it showed that the activated carbon has larger absorption capacity to phosphorus compared to Zeolite. However, Zeolite has higher absorption capacity to ammonia compared to the activated carbon based on Frandish model. And next, removal of phosphorus by activated carbon and Zeolite did not fit both Lamia and Frandish model. This in contrast with ammonia removal by activated carbon and Zeolite. It correlates with both Lamia and Frandish model. And lastly, based on the analysis, activated carbon at 31.75 gram pH 7 and 1 hour is suggested to be used for hospital wastewater treatment. However, this is a theoretical assumption as it did not include other factors such as presence of other ion or molecule because it will compete with the phosphorus and ammonia for the absorption. Thus, the real experiment can be carried out to check the influence. That's all from me. Thank you.